Howdy folks, I'd like to share an idea, and in the next video I will share also another idea which is totally different, but also an idea I came up. For both ideas I wrote a little paper on academia.edu. You can find them, I will put them down here in the link down below here. And I like to share, but I like to point it out. I drew a graph for it, and I want to convey this do-it-yourself experiment for the professional hobbyists, for yourself. So I hope you like it, and who knows what comes out of it, and who knows what result this might bring. I'm going to tell you in advance that the results are most likely not going to be as we want it to be, but at least we can set an upper limit. It has got all to do with the double slit experiment of Thomas de Jong, and he performed that in whatever, I don't know, I forgot, somewhere 1800, something like that. And he showed that light is a wave. Later on that was repeated with electrons and protons and even bigger particles up to 10,000 atomic units. That was, as far as I know, the biggest mass that was being used in those experiments. And yeah, that's nice. But we can do this experiment at home, but then also with larger particles, larger objects. And based on that, we can set an upper limit. I mean, you can approach this problematic thing from 2 points of views, starting from the low end, from the electrons, atoms, molecules, and so on. But you can also start it from the high end of the particle sizes, and that's what we're going to do here. So we can set an upper limit, and most probably if we're going to do this experiment at home, at our own homes, we're going to fail in getting the pattern, in the interference pattern that we want to see. But at least we can set an upper limit for these type of experiments. Well, how can we do that? It's pretty simple, actually. And I drew it out on the board here. Well, what you can do is you can take simple spray paint, simple spray. I'll take a canister of it. I have a canister of it. And I did this experiment, and of course I didn't get the desired pattern. But a simple spray paint in black in this case. And what I did is I put some popsicle woods together, I glued them together and made some slits over here. Of course I didn't get the pattern, and I put a white paper behind it. Of course I did not get the pattern of the interference pattern, but two blobs basically. But it was a starting point, you know. You had to start somewhere. But what you can do is with the spray paint, put it over here, you can do that because the particles in spray paints are very tiny. At least the very tiny ones are very tiny. So these are in the order of magnitude of what is it? 10 to the minus 18th liter. I calculate that in the paper, as you can read it for yourself. So it's very tiny. Now, if spray paint doesn't do it, and you can just simply spray paint it on these patterns, and well, in my case I didn't get the interference pattern, but the two blobs. But if you exchange the spray paint, in this case I used black spray paint. If you exchange that for a salt solution, an ammonium chloride solution, ammonium chloride in methanol or in acetone, and you perform this same experiment in a heated environment, like an oven, a big oven-like environment, and then the last paper you take paper drenched in silver nitrate, and then dry it until the paper is moisty, and then you hang it out, because the chlorine of the ammonium chloride solution in methanol or acetone will react with the silver ions, and it precipitates as a black spot on the paper. So but what happens is that if you do it in a similar way with you have those deodorant sprays. I can show you one. Well, this is the one that I'm using. Well, instead of deodorant, you can also fill it with ammonium chloride dissolved in methanol or acetone, in which it dissolves better. And if you spray it, then you get very teeny tiny, how to say, aerosols. And these aerosols, especially if they're made up of ammonium chloride dissolved in methanol or acetone, the methanol or the acetone will evaporate, especially in a warm environment like an oven, and so that you will be left with these particles will be the crystals released from that solution, so they are even smaller with a certain speed, and if you put this in an oven or even an evacuated oven, and you can evacuate it simple by a vacuum cleaner that also delivers some vacuum. You don't need to have a deep vacuum, but if you can, of course, even as a hobbyist, if you do have a vacuum pump that's very strong, you can use, of course, a deeper vacuum. But if you don't have that, you can do it also with a vacuum cleaner, which gives a decent vacuum. If you saw the Mythbusters, then you know that a vacuum cleaner can lift up a car. So it's not that strong, but strong enough to lift a car if you do it properly, as the Mythbusters did. And so you can create a little under pressure in such an oven. And if you raise the temperature to 60 to 90 degrees Celsius, then the methanol or acetone will evaporate very rapidly. And then what you are left with is the particles is crystalline ammonium chloride, and that will react with the silver nitrate, and it will deliver some spots on the paper. Now, because the droplets are pretty big compared to the particles that you want, but if you evaporate the methanol or acetone, the crystals will be smaller, of course. So then you have particles that are smaller than the droplets that you originally started or that you sprayed in there. In this way, we can downsize, because most probably we have to downsize this do-it-yourself experiment. You can start big and set an upper limit, and you can even film it, and especially if you have a high-speed camera, I don't, but if you have, you can even calculate the speeds, and it would be a nice experiment to do it. And then you can set an upper limit of the molecular weight of the crystals that cause a two-blob interference pattern, or a real interference pattern with more than one interference. How do you say that? Well, it's such a stripe, such a thing like that. So that is the experiment that I like to convey to you, that you can do this yourself at home, and at least the minimum thing that we can do in this kind of experiment is set an upper limit or a lower limit, an upper limit to where the macroscopic objects create or do not create interference patterns, because that's the goal, interference patterns. But if you don't succeed, then at least you have, and you recorded it well, and you measured the speeds of the crystals very well, then at least you have an upper limit to where we can expect some interference patterns. In the paper I wrote also some kinds of the wavelengths, the de Broglie wavelengths, which can be created by these crystals. And yes, it's not going to be an easy experiment, not even for hobbyists, professional hobbyists, because it's the effect is very small. But at least we can set some upper limits, and that would be cool as well. That is a scientific result as well. But if you had positive interference patterns, then yeah, well, then you, would be worth something to somebody. And you should please share that as well. I mean, my experiment so far failed. I just got two blobs. But okay, that's fine. I mean, that's a result as well. I mean, at least, and I know that this is not that I have to downsize it again. And it's a matter of downsizing and going from coarse to finer and finer, more optimal conditions to which might produce interference patterns. And that's the whole goal of this do-it-yourself interference experiment. Okay, this is what I want to share in the first place, and I'm going to prepare the board for the other thing, which is a little bit bigger than this experiment, but I will show you in a moment. Okay, thanks for watching. See you next time. Hasta la basta. And success. And please, if you have some results, please share it. That would be great. Okay, I'm looking forward to your reactions on this do-it-yourself experiment. Okay, thanks for watching. Hasta la basta. See you next time.